The load-sharing fault alarm and parallel direct current uninterruptible power supply systems typically occurs when there is an imbalance in the load distribution between the two UPS units. When the load shifts suddenly to one UPS, the other UPS experiences a significant decrease in load, potentially triggering an internal imbalance. This imbalance is what often sets off the fault alarm. Several steps can be taken to address this issue. Firstly, check the load distribution. Ensure that the load is distributed as evenly as possible between the two UPS systems. This can involve manually adjusting the connected loads or utilizing an automatic load balancer if available. Secondly, verify the UPS capacities. Ensure that both UPS systems have sufficient capacity to handle the expected load. If one UPS is significantly smaller or has a lower capacity than the other, it might struggle to handle sudden load shifts effectively, leading to the fault. Thirdly, check the UPS settings. Verify that the UPS systems are properly configured for parallel operation. Key settings to examine include synchronization parameters, load sharing configurations, and communication protocols. Ensure that these settings are compatible between the two units. Fourthly, inspect all cables and connections. Carefully inspect all cables and connections between the UPS systems to ensure they are secure and in good condition. Loose, damaged, or corroded connections can cause communication issues and lead to load imbalances, contributing to the fault. Fifthly, consider updating the firmware. Check with the UPS manufacturer to see if there are any available firmware updates for your UPS models. Sometimes, firmware updates can resolve underlying issues related to load sharing and overall system stability. Sixthly, perform a soft reset. Try turning off both UPS systems and then turning them back on. This can help clear any temporary faults or communication errors that might be causing the issue. Seventhly, contact technical support. If the problem persists, despite these troubleshooting steps, contact the UPS manufacturer's technical support team. They can provide further assistance in diagnosing the problem and recommending specific solutions based on your UPS models and configuration. Additional tips to consider include using a UPS monitoring system to actively track the load distribution between the UPS units. This allows you to identify any imbalances early on and take corrective action. Performing regular maintenance on the UPS systems is also crucial. This includes tasks like battery replacements, cleaning, and inspecting components for wear and tear. Finally, consider using a static transfer switch, or SDS, instead of paralleling the UPS systems directly. An SDS provides seamless and automatic load transfer in the event of a fault, preventing imbalances and ensuring a continuous power supply to the connected equipment. I will provide more details for these tips now. Let's begin by delving into load distribution. Ensuring equal load distribution between the two UPS systems is vital for stable parallel operation. An imbalance can lead to one UPS being overloaded while the other idles, triggering the fault. Manual load adjustment involves strategically assigning devices to each UPS to achieve a balanced load. An automatic load balancer continuously monitors the load on each UPS and automatically adjusts the distribution to maintain equilibrium. Next, we will talk about verifying UPS capacities. Each UPS must have the capacity to handle its share of the load, including potential surges. Consult the UPS specifications to determine their load ratings, typically measured in watts or volt amps. Compare the load ratings to the actual load connected to each UPS, ensuring a sufficient margin for unexpected load increases. Now, we will discuss UPS settings. Correct configuration of UPS settings is essential for proper parallel operation. Synchronization settings ensure that the two UPS units operate in phase, preventing voltage or frequency differences. Load sharing parameters define how the load is distributed between the UPS systems. Communication protocols enable the UPS units to exchange data and coordinate their operation. The communication protocols can be proprietary. Moving forward, we will discuss inspecting cables and connections. Secure and reliable cable connections are fundamental for transmitting power and communication signals. Loose connections can cause voltage drops, overheating, and communication errors. Damaged cables can lead to short circuits, power interruptions, and even fire hazards. Visually inspect all cables and connections for signs of damage, corrosion, or looseness. Tighten any loose connections and replace damaged cables immediately. Concerning firmware updates often include bug fixes, performance improvements, and new features. Check the UPS manufacturer's website or contact their support team for the latest firmware versions. Follow the manufacturer's instructions carefully when performing a firmware update to avoid damaging the UPS. A soft reset can resolve temporary glitches and restore normal operation. To perform a soft reset, turn off both UPS systems and disconnect them from the power source. Wait a few minutes, then reconnect the power and turn the UPS systems back on. Let's talk about contacting technical support. The UPS manufacturer's technical support team has specialized knowledge and expertise in their product. They can provide guidance on troubleshooting complex issues, interpreting diagnostic data, and implementing corrective actions. Be prepared to provide them with information about your UPS models, configuration, and the specific symptoms you are experiencing. About UPS monitoring, a UPS monitoring system provides real-time visibility into the UPS performance, including load distribution, voltage, current, frequency, and battery status. This data can help you identify imbalances, detect potential problems, and optimize the UPS operation. Many UPS systems come with built-in monitoring capabilities, or you can use a third-party monitoring solution. Regular maintenance prolongs the UPS lifespan and ensures reliable operation. Battery replacements are a critical part of UPS maintenance. Batteries degrade over time and need to be replaced every few years depending on the battery type and usage conditions. Follow the manufacturer's recommendations for battery replacement intervals. Cleaning the UPS removes dust, dirt, and other contaminants that can accumulate inside the unit. Use a vacuum cleaner or a soft brush to clean the internal components, being careful not to damage any sensitive electronics. Inspecting components for wear and tear helps identify potential problems early on. Look for signs of overheating, corrosion, or physical damage. Replace any worn or damaged components immediately. Now we will cover static transfer switches. An SCS offers a more robust and reliable solution for ensuring continuous power supply. An SCS automatically switches the load between two independent power sources, such as two UPS systems or a UPS system and a utility power source. The transfer happens seamlessly and instantaneously without interrupting the power supply to the connected equipment. This eliminates the risk of load imbalances and ensures that the load always has a stable power source. To recap, troubleshooting a load-sharing fault alarm in parallel UPS systems requires a systematic approach. By checking the load distribution, verifying UPS capacities, confirming UPS settings, inspecting cables and connections, updating firmware, performing a soft reset, and contacting technical support, you can identify the root cause of the fault and implement the appropriate solution. In addition, utilizing a UPS monitoring system, performing regular maintenance, and considering the use of an SCS can further enhance the reliability and availability of your power supply. Understanding how load sharing works is also important, so let's cover that now. Load sharing in parallel UPS systems is a technique used to distribute the electrical load evenly among multiple UPS units connected in parallel. This configuration enhances the system's overall reliability, redundancy, and capacity. When multiple UPS units share the load, the failure of one unit does not necessarily lead to a complete power outage. The remaining UPS units can continue to supply power to the load, albeit with reduced capacity. This redundancy is crucial for critical applications where uninterrupted power is essential. The load capacity of a parallel UPS system is the sum of the individual capacities of the UPS units connected in parallel. This allows you to increase the total power available to the load without having to replace the existing UPS units with larger, more expensive models. Load sharing ensures that each UPS unit operates within its optimal load range, maximizing efficiency and prolonging its lifespan. When a UPS unit is heavily loaded, its efficiency decreases and its internal components are subjected to higher stress levels. By distributing the load evenly, you can improve the overall efficiency of the system and reduce the risk of component failure. Several methods are available for implementing load sharing in parallel UPS systems. One method is droop control, which is a decentralized control technique that relies on the inherent characteristics of the UPS units to achieve load sharing. Each UPS unit is programmed with a slightly different voltage or frequency set point. As the load increases, the voltage or frequency of each UPS unit decreases proportionally. The UPS unit with the higher set point will supply more power to the load until its voltage or frequency drops to the level of the other UPS units. Current sharing is another method that uses a centralized controller to actively monitor and adjust the current supplied by each UPS unit. The controller sends signals to the UPS units to increase or decrease their current output until the current is evenly distributed among them. Digital communication protocols are used to exchange data between the UPS units and the controller. This method provides more precise load sharing than droop control, but it also adds complexity to the system. Automatic load transfer switches are also a consideration. An automatic load transfer switch automatically transfers the load from one power source to another in the event of a failure or overload. This ensures that the load always has a stable power source, even if one of the UPS units fails. The load transfer is typically seamless and instantaneous, without interrupting the power supply to the connected equipment. Proper planning and implementation are essential for successful load sharing in parallel UPS systems. The UPS units must be compatible with each other in terms of voltage, frequency, and communication protocols. The UPS unit should have similar load capacities to ensure that the load is distributed evenly. The UPS units must be installed and configured according to the manufacturer's instructions. The UPS system should be regularly maintained and tested to ensure that it is functioning properly. When choosing UPS systems for parallel operation, it is important to consider several factors. The UPS unit should be designed for parallel operation and have built-in load sharing capabilities. The UPS unit should have a high level of reliability and redundancy to minimize the risk of failure. The UPS unit should be easy to install, configure, and maintain. The UPS unit should be cost-effective and provide a good return on investment. Load sharing is a crucial technique for enhancing the reliability, redundancy, and capacity of UPS systems. By distributing the electrical load evenly among multiple UPS units, you can ensure that your critical equipment always has a stable and reliable power source. Careful planning, implementation, and maintenance are essential for successful load sharing in parallel UPS systems.